Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my pleasure today to welcome Professor John Stasko from Georgia Tech University. John is a colleague and friend who works in the area of information visualization, peripheral awareness, and multiple monitors and large displays. We've had the benefits of not only working with John over the past few years, but also having his students as interns, and that's been to great effect. So I think you'll enjoy everything John has to say about his area of research today, and so without further ado, I'll leave him to it.
Okay, thank you, Mary. My title is Information Interfaces, Blending InfoVis and HCI. My research group is Info Interfaces. So largely today I'm going to talk about the kinds of work that we do. The web and the internet have, over the last 15 years, have really given us access to more and more information. There's arguments about whether there's more information out there or not, and I don't want to go into that debate, but I think we can get at a lot more now. I wish I had the reference for this, or I read somewhere that has estimated that the average large Sunday newspaper of a city in the U.S. has more information in it than a person in the 1600s encountered in their lifetime. Now, I don't know how they're speculating on that and how it all goes, but that's essentially, there's a lot out there. Richard Saul-Moerman, in his book Info Anxiety 2, the follow-on book, coined this term prosumer. We've all become prosumers, consumers and producers of content. Because we can independently access previously unavailable information, many of us are empowered, more involved in researching the pros and cons of various decisions we make about all aspects of our lives and work rather than relying on experts. We just don't want to know the ingredients in the mayo. We want to know where the eggs were laid, what the chickens were fed, what effects the preservatives will have on our health. So we can dig into all these kinds of things. And I think our challenge then is helping people to benefit from this data and not feel swarmed under or snowed under by it, which I many, many times feel, getting at the right stuff and gaining insight from it. My research group has adopted this Dilbert cartoon, and it's what we're all about. People are getting stupider every day, relatively speaking. The complexity of the world's increasing geometrically, but your ability to learn is the same slow trickle it's always been. Information's gushing toward your brain like a fire hose aimed at a teacup. And Bill Buxton has this wonderful slide about human cognitive ability being this flat line, and everything coming at it getting bigger and bigger all the time. So this really speaks to what we're all about. So today, as I said, I talk a good bit about my research group and what we do. And I think InfoVis, one of the main ideas there is you take the data, which is just the numbers and the text and all those things, and you transform it into information, which is that has insight and understanding and meaning in it. And one thing I want to highlight today, I'm going to show a lot of work that is the work of my group, a lot of very talented students, and so they've various different students have been involved in many parts of it, and in the corners I have some highlights of references and things, but really get to showcase a lot of their work today. The kinds of things we do range across a broad spectrum. Information visualization, probably the biggest area of work that we've been doing, but things like ambient displays, peripheral awareness, and even I have one PhD student working on embodied agents right now. And they all, I think, are ways that can help people take advantage of information. So today is a Red Lobster sampler platter day. You get a little bit of a lot of different things. But I didn't want to just kind of hit and miss across that. So I tried to reflect on some ideas or themes that permeate some of these projects. And I pulled out 3 that I'll highlight today, and within each show 2 or 3 particular projects that touch upon those. The first one is in the area of information visualization. There's a lot of banging, interesting representations, but I think the interaction is really kind of a big part of where we're going to see advances down the road. I think it's just as important. So, the term should be information visualization and interaction. It's kind of, the little brother that always gets, forgotten, or interaction's really key and really important. How you navigate and move around between views, how you drill down and focus on certain items. There are just only so many interesting representations, and that area has been mined pretty hard, and to come up with new visual representations is very, very challenging. But I think there's still a lot of room on the interaction side. So let me show a couple of case studies that I think start to illustrate this. First one is just a classical InfoVis problem looking at hierarchies. Could be org charts, OO software organization, your file system, things like that. There have been a lot of visualizations produced of hierarchies. It's perhaps the classic InfoVis problem. I think you see the most papers on year in, year out. My group, we developed a technique called SunBurst that's a space-filling technique, kind of like tree maps are, but it's radial rather than rectangular. And the idea is that in the center of the display is your root, or the focus of your hierarchy. And then as you go farther out, you're going deeper down. And in a tree map where area corresponds to the size of the entity, in SunBurst, it's angle swept out by it. It's not area, because as you get further out, you get bigger and the areas change. And so we developed the system SunBurst. It's just a little file browser, for instance. But the problem with this is the files you care about, the leaf nodes kind of down at the end, become these little small thin things out at the boundary, and there's just not much there to poke at and look at and put queries against. So what we did is we thought about, well, it's not just a visualization of that'll help, but it's some kind of interaction to zoom in and look at the details. We developed 3 techniques to essentially drill down and focus on items, and I have a little video that will show part of that. Again, since it's interaction, demonstrating the technique, I think is really key and important.
This video illustrates the SunBurst visualization system and 3 focus plus context techniques for examining small peripheral items in the display. Shown here is an example computer file and directory structure. The SunBurst interface has 3 main regions: the file display area on the left, the control panel in the upper right, and the color legend at the lower right. To begin, only the root directory or folder is shown, but the viewer can step deeper into the hierarchy via interface controls. Each successive level of files and directories is shown further from the center. White slices represent directories, and colored slices represent files. The angle swept out by a slice corresponds directly to the file or directory size. The color of a slice normally represents the file type. Alternatively, color can represent when a file was last modified. Here, the red files have been changed recently, while the dark blue files have not been modified in many years. The main problem with this type of visualization is the thin size of small peripheral files that makes it difficult to see and analyze them. Some examples are being pointed out here. When files are so thin, they become virtually indistinguishable. We have developed 3 focus plus context visualization and interaction techniques to address this problem. Shown first is the angular detail method. When a directory is selected via a double click, we shrink the entire structure, highlight the directory, move the structure to its opposite boundary, and expand the selected directory and its children. User interface controls allow the viewer to adjust radii and sweep angles of the focused directories and files. The technique uses smooth animation and contextual layout to help the viewer track interface transitions and examine the selected peripheral items. Note that in addition to selecting a focus item from the normal view, a user can select a new focus item from the shrunken overview as well as from the enhanced focus region of the visualization. This may assist the viewer to select items that are too small to be distinguishable in the overview. Here, we select a relatively interior focus directory in order to examine all its children in more detail.
Let me stop it there. There's a couple of other techniques, but you get the idea there that it's focused on the animation's really key and important to show the transitions, but we really wanted to always have an overview there, even if it was shrunk down, so you always kind of see where you're coming from, but then blow the details out and just give that a lot more real estate to work with. So just the items that I hit on there. The second case study deals with investments and mutual fund portfolio diversification. The mutual funds are just collections of stocks. Have professional managers. When you don't want to worry about doing the stock picking yourself, buy various mutual funds. And one of the keys with it is if you hold a number of different funds, you want to get some diversification. You want to hit different sectors. If you have funds that have a lot of common stocks being held within them, your portfolio is not really diversified, and you may not be making the investment gains that you could. One of the themes of this is showing zero-valued items can be kind of showing nothing can be important at times. And where does that come out? Well, in fund portfolios, they may have 20, 50, 100, maybe even 200 different stocks. And that is the collection of stocks that the manager has chosen to be in them. I may want to see across the different funds where are the overlaps. I hold 3 funds. What stocks are being held? What sectors am I not covering in my portfolio? So how do we get at that? Well, probably my favorite InfoVis ever built, the Map of the Market by Martin Wattenberg, shows the overall stock market, the regions or individual stocks, the size of a rectangle is the market cap of that company. And we could do a similar thing for a portfolio where you just show you stocks that you hold, in whatever sectors, and that would work out. That would be fine. But I think a key thing in this is what don't I own? What might I want to purchase? And those are stocks I have no investment in, so I have zero net worth, no area. There's no rectangle. There's nothing there. So how do we deal with that? Well, we came up with the notion of what we call a context tree map, where it's a simple tree map that gets distorted a little bit, where the zero-valued items have to be represented somehow. There were about 6 or 7 different ways that could be done. You could do exponential functions to map values, so 0 gets mapped to 1. You could do different things. The technique we came up with was to reserve a portion of the display for these entities. And then however many of them there are, you just divide that space between these. So these zero-valued nodes get a small chunk of area. It comes up with a visualization that looks a lot like the classical tree maps, but actually let me show it to you here, this tool. I think it starts to get a flavor of, so I'll load some data. And this is just, I think like 6 or 7 years ago, a bunch of stocks and sample mutual funds that we had. And here, see a bunch of different market sectors, so durables, health, financial, staples, etc. And I can look at different stocks. So maybe Acorn International is one, and I click on it and I see, okay, which stocks in what sectors does that fund hold? What would you buy? Now, that perhaps I got a tip that looks interesting to me, so I'll buy $1,000 worth of that. And I start to see what are the individual stocks that are held. So for my $1,000, I have essentially $12 worth of this company. And now I choose to buy that. So maybe give that a soft yellow and do that. And I can add that stock to my depot, which is kind of my holdings. But I can look around, and here in this sector, staples, I'm not really covering anything. And maybe I really, Heineken's the way to go, and I want to buy some Heineken. So I just click on that, and so output becomes input. So now I've filtered, and in this region here, only the funds that hold that stock appear. Okay, so I can see, which funds am I looking at? So look around in here, Target. Okay, well that's interesting because I get some other coverage in this sector, and actually this sector that I had nothing in, it has pretty good coverage. So that looks kind of good. So maybe I'll buy 2,000 worth of Target, and again I start to see things as they come up. Say okay, and now my portfolio starts growing, and I start to see coverage, and I can go back and forth and ping pong in this way toward, okay, what stocks and what funds are they in, and now what fund, how these funds work. But again, it's all in this interaction. It's the querying. It's going back and forth. shut that down. Go back in. Okay. So again, context is a really key dynamic query aid here. Context is very, very important. We're using brushing and filtering across it. There are a number of other features I didn't show there. And it's kind of one big flat window. Display, I want to show everything and show how your interactions affect the data set that we're working with, the stocks and funds. The final one I want to show is a new system that was developed by a student in my InfoVis class, and then he and his advisor, Julie Jacko, and I kind of pushed a little further on it. It's a basic multivariate visualization problem. And I think a lot of the techniques that have been developed are somewhat hard for people who haven't been trained in those areas to understand. We tried to get at, is there something simpler that we could do, much more visceral, metaphorical that we get at? And it's this idea of when you were a kid, you might have played with magnets and nails and little metal dust and iron dust and things like that. So we've developed a system called Dust and Magnet. Okay, and the idea is relatively straightforward. I'll show a demo in a second. The little bits of iron are your data cases, your data points. The magnets are the variables on your data set. I'm going to show an example with cereals. So the variables might be, sodium content, fat, vitamins, things like that. And the individual data cases are Cap'n Crunch, All Brand, Special K, things like that. But again, the interaction is really key. So, and this, take that down. Come back here. Just want to move this. Okay, let's make that big. And we're going to go up here. Let's pick cereals. Okay, so, oops. Yeah. So I'm going to do some mappings first. So color, I want to be manufacturers. Okay, I'm just going to put that on. Size, let me hold off on that a second. So now I can start to bring about, actually, let me center the dust again. So let me put one magnet on fat and another one on maybe fiber. Okay, so I'm going to bring this down here. Whenever I move a magnet and interact in any way, the points are drawn as you'd expect. So if something has a very high value of fiber, it's drawn more strongly toward it. And if it has a very low value, you can think about it being repelled. All the magnets that are visible on the screen are influencing the data. So I can essentially just grab it and kind of move it around, and we start to see things come up. Well, 100% natural bran. Okay, low fat, high fiber. On the opposite end, some Kellogg's. Actually interesting, all bran with extra fiber. That's kind of curious. That might be, okay, let me take a look at my data set. What's going on? Is there some issue with that? But there might be some other stragglers, all bran. So these are high, okay? But this natural brand seems, what's up with that? There's something in there also that may be high fat. And then some of the, the usual candidates, good old Captain Crunch, et cetera. But we can bring more things out. So if you care about protein, okay, and I kind of move things around and see what Cheerios, okay.
So the more you move them, it's just moving the magnet, like jiggling?
Yeah, jiggling. There are commands. I can hit special keys to do it. There are menu commands, or I can actually take the magnets and drag them around. Then, I can do other things. So size, I might put on calories, and maybe we want to go from a radius of 6 to something like 12. Okay, and now the dots start to change. So I can just use different visual variables essentially to get a handle on it. What we found is really important with this is you want a checkpoint a lot of times. You want to save a state because it's hard to get back to a certain point. So we have features for logging that. And some usability studies and some evaluations we've done of this. It's an interesting one. People use it in very different ways. They stack up magnets all the same, or they kind of lay them out around a grid. We found some really interesting usage patterns that we want to study a little bit more. And Jisoo Yi, the student developing this, is looking at kind of decision support processes, and might this help with things like that. All right, let me shut that down. Okay, so again, very metaphorical view, very direct manipulation, hands-on, and interaction is just fundamentally a part of the visualization. So along this first dimension, interaction, I think that's where a lot of the innovations are going to be in the field of information visualization down the road. In the Illuminating the Path, the National Visualization and Analytics Center, headed up by Jim Thomas at PNNL Labs, down in Southeast Washington, there's a whole chapter that talks about developing this science of interaction, where the deep understanding of it to the same degree that perhaps we have with representation and presentation right now. So that's, I think, an area for further work. The second main area or principle I want to talk about is understanding and addressing your user's task. And certainly in HCI that kind of goes without saying, and it's kind of preaching to the choir here, I know. But I think in the area of information visualization, it's too often overlooked a bit. There are a lot of, I see papers submitted, these kind of visualizations in search of problems. Here's this cool 3D rep we have, the classic website 3D viz that I don't think I've ever seen one that would be helpful for all that much. But a lot of them are out there. And when I look at them, I think, okay, what real task or goal will someone have that this will help with? And I think that's a key question to ask. So in our work, we've focused in on this, and we've looked at a range of activities or objectives or goals someone may have, and think about what kinds of visualizations would assist with it. Well, one of the particular things we looked at are kind of lower level activities, kind of the nuts and bolts of when you're interacting with a visual tool and you're trying to solve problems. Are there categories of analytic activities that people perform when using InfoVis, and if so, what are they? There's been a number of different task taxonomies created, but their focus wasn't always in InfoVis, but it may have been creating artifacts, building presentations, or various human tasks. They developed things that look like this. Some of them are quite old, so around 90. Clayton Lewis and a student of his, Warren, came up with this user task taxonomy, primarily SciVis they were looking at the time. Schneiderman's mantra, the overview, zoom info, so that pulls out some tasks too. Steve Feiner and Michelle Zhou as well, in the context of preparing automatic multimedia presentations, came up with task taxonomies. But in looking at all of these, I think for InfoVis, there's a slightly different high-level goal, so I'm not sure these taxonomies quite matched up. And then some of the particular sets, there were things that seemed to be missing or left out to me. So we thought about how to get at this a little more. And what I did is I used my class that I teach pretty much every spring back at Georgia Tech, 7450 InfoVis, and I have an assignment where I have the students work with a number of commercial tools: Spotfire, Eureka, the table lens, InfoZoom, InfoScope, things like that. And what I do, here's a picture of the assignment, is I have some sample data sets. And I give out 5. The students have to pick 2. They work with all the different tools on these data sets. But up front, they're supposed to come up with some problems on the data. The serials one is one that I use. So they have to come up with some questions and then critique how the different tools help them to solve or answer those questions and problems. Okay. So what I did is I took all their assignments from one year and I looked at these questions that they generated on the data sets. Here's the particular data sets they had. We had serials, mutual funds, cars, films, et cetera. How many data points within them, how many variables. And then the students, how many questions the students generated in these assignments. Nearly 600. I took all these questions and we basically did affinity diagramming. Okay? We printed them out and we cut them up. And so we had 600 little sheets of paper. And we set them on a big conference table in my lab, and we started pushing them around and finding what settled and kind of zooming in. We started building up categories, and this is like this, and we'd come in one day and we'd shift them all around and move them. My whiteboard grew when we were working on this, and we had all kinds of things, and we'd erase and move around and settle. But ultimately, we came up with 10 kind of low-level categories that emerged out and had big clusters of questions in them. I'll run through them quickly here. First one we call retrieve value. So given specific cases, find attributes. You know, what's the MPG on the Audi TT? How long was Gone with the Wind? Things like that. Filtering is kind of that in reverse. Given conditions on values, find the cases. So what serials have high fiber? What comedies won awards, et cetera? Things like that. Something compute-derived value we saw. Given cases, do some numeric representation or value on it. What's the income of all stores? How many manufacturers of cars are there? What's average calorie? This kind of operation on top of it. Extremums, very common. Okay, what's the best for this? What's the worst for that? Examples, quite common. Sorting, right? Just sort it out. Give me a sorted list here. Ranges. A lot like sort, but subtly different in certain ways. Given some cases, what's the range of lengths? What's the address? Things like that. Seventh one, the distribution. What's the distribution across a variable on a particular, you know, what are carbohydrates across these cereals? Eighth one, anomalies, outliers. Okay, another common question that people came up with. In the cereals, are there outliers in proteins? Are there exceptions? So on. Clusters. Okay, people want to look. What goes together? Are there clusters of typical film lengths? And then the final one, perhaps the biggest, correlations. Okay, people want to do correlations all the time. Are these two variables, or maybe these three variables, correlated in some way? Okay, so those are our categories, and that really encompassed a lot of those questions. But I think some of the interesting things come up in what's not there. What are outside of that? Well, there are compounds. Think of these as the atoms, and you can put them together to make the molecules. So sort the manufacturers by average fat content. Well, you have to figure out the average fat, and then you do this. You know, so it's just, and people come up with queries like this. Basic math we left out. You know, is this or this higher? There's just kind of a fundamental mathematical comparison that we didn't have as part of it. Uncertain criteria. So question, you know, does all bran with fiber sound tasty? You know, well, what do you mean by tasty? It's a higher level kind of question or activity. Transitioning down to the next one. You know, how do mutual funds get rated? Well, that's a higher level, you know, probably in doing that, you will be doing a lot of these low-level 10 tasks. But that's operating at a higher level than we were focusing on here. It's a perfectly valid task. It's a reasonable question to be asking. It's just not kind of one of the atoms, the way we looked at them. George wanted.
One of the things that was left out is what was left out. That is, the gap analysis didn't occur on there.
We didn't have questions.
And obviously, when you did this analysis, you did a gap analysis. This is it.
That kind of question really didn't occur in the data set. And I'll come back to maybe issues with the data set, too, in just a moment. And then some of these other taxonomies had comparison. We left comparison out because it's, at some level, very qualitative, very, you know, how does a RAV4 compare to a CRV? Well, what low level, you know, what do you mean by that? That's a more complex, higher level kind of cognitive issue, I think. So some concerns. Clearly, the tools the students used, and they saw little previews of them, may have influenced the questions they came up with. These were graduate students. Okay, would we get a different set if we went to intelligence analysts or microarray researchers or software developers? Probably, although I have a whole other discussion. I think it actually wouldn't be that different, but that's another discussion. But clearly, and it's subjective. This isn't an exact science. I mean, literally the last day do we have 11 or 10? You know, and there was this one. Does that go? And there's no exact science here, but those seem to be the kind of things that emerged. What we wanted to do in this was find some grounding for these low-level kinds of tasks, and then our hope is that these tasks can serve as a kind of vocabulary when you build your InfoVis system N+1. Talk about how it supports 1, 2, 3, 4, and gives you a way to compare and assess and evaluate and talk. And that's really what we're seeking to help out. And again, it pushes on this notion of kind of end-user goals and tasks. Now, I hinted at, okay, so low level, what's up higher? What do people do with InfoVis tools and data? Well, they do complex decision making. They learn a domain. Okay, I'm not familiar with it. I read in this data set, and I want to learn all about it. I figure out trends. I predict the future. I figure out what stocks to buy. Okay, these are much higher level, and presumably in doing any of these, you're doing many, many of those low-level tasks. Okay, but what I think we've noticed in InfoVis tools is that oftentimes they inadequately support these kind of decision-making tasks, these high-level notions. And we make an argument that many visualizations have been designed with what we call representational primacy, a kind of appropriate, I want my viz to be truthful. I want it to show the data and be a little bit of Tufte-esque kind of an argument. But there's more than that, okay? There's more than just telling the truth about it. There is helping analytic tasks that people are trying to accomplish. And what are those things? So we've looked at, pulled out what we call a worldview gap and a rationale gap in moving from data and analysts kind of perceiving the data in a visualization to these higher level activities. And these gaps are when concerns may come up in do the tools support me in doing the analysis that I want to carry out? And I think what needs to occur here are some of the decision support tools, data mining, analysis goals, that needs to kind of come closer and merge with InfoVis systems, and there's a kind of common middle ground. Not that often now do we see data mining researchers collaborating with InfoVis people and trying to understand and take advantage of the benefits of each of those, the more automated algorithmic approaches or the more human-centric perceptual-driven approaches. And I think some of that needs to come together. So, future work here, one is understanding visualizations and the insights they provide. A key to evaluation beyond, simple usability and can someone work with a tool, is a visualization helping someone really, gain key insights and understanding. Insights are clearly very subjective. Okay, so that's the challenge in that kind of evaluation. But I think more and more as we do this, we'll get into a better place of comparing one visualization to another. Then the final principle I want to talk today about is utilizing kind of opportunistic and peripheral channels to communicate information to users, help them to learn. And I showed a lot of websites early on, but I don't have time to surf the websites all that much and look at things. I'm busy. Web access is clumsy and getting at things. It's gotten better, but still it takes time. So can we use the kind of little breaks in activity during the day that we have when we're not engaged in some primary task to maybe opportunistically, serendipitously come upon information that may be of use to us? I mean, people are very good at peripheral awareness, the cocktail party effect and hearing things we're good at. So can we take advantage of that? Well, talk about a system here called the Buzz, probably for Georgia Tech Yellow Jackets, that helps people that helps push information essentially to people in opportunistic ways. Our delivery platform was thinking about screensavers in our original concept, but large public displays are another possibility. So big plasmas or LCDs in the hallway, maybe projected on the walls. The idea here is that we create collages of information and images taken from websites, and we just put up a different collage about every 45 seconds to a minute. Show it, move on to the next one. There's two kinds of information we draw upon. One, local community information. Our College of Computing website, about a year or so ago, we had 17,000 unique pages. So we just go crawl it. We run a crawler through. We randomize all the pages. We just randomly pick one. Okay? We grab the images off it. We make a collage, and we show it. There's other kinds of information, external information, weather, traffic, stock news, etc., and we can present collages of those too. So here, start to see in the corner of my lab, we're just projecting, and the buzz is kind of up there. We have a tower of CRTs too. Or it might be on, if you have a multi-mon system, and it may be running on a side monitor, or maybe up on an LCD there. As you can see in my labs, we like displays. We have lots and lots of displays. So to give you a flavor, you have to kind of see this. Let me show you some buzz collages. And I'll start off with the community stuff, the kind of stuff that just pops up. So there's, assignments. This is actually one for my InfoVis. Someone's created a web page for some work that they've been doing, and we just see collages of images, or maybe research projects they're working on. Okay? And we're just pulling images from the pages. But you also get a lot of personal information, and people take trips, and they have images that just kind of come out. And so Valerie's hiking somewhere. Someone touring Europe and taking pictures from the turkey bowl, things like this. I've had comments, this system gets run a lot around, and I've had faculty, oh, I didn't know Rodney got married, things like that pop up. Because you don't have time to look at the web page, but these things are just there, and they're in your screensaver, and they pop up. Other kind of interesting images and pictures that just go past. And just the title of the page and the URL down at the bottom. One of my PhD students is a very good photographer, and he has kind of a photo blog, and he has some really nice pictures. People's vacations, and I'm a Japanese maple tree collector, so that's one of the pages of mine that came up. So that community stuff that just kind of goes past. But now in the buzz, an earlier system we had called What's Happening really focused on this community information. In the buzz, we're getting at more of this value added collages, and in a way, sideshow on steroids. Kind of think about it, and really pushing out that kind of information. But we have more pixels, we have more real estate to work with. So there's the stuff you'd expect, stock information. The weather pages come up, and we show the satellite images and things. In Atlanta, an extremely important page is the traffic page. And it's opportunistic. So weekdays at 4:30, this collage gets much higher priority. So it appears like every third collage it comes up. Some traffic cams. Atlanta had a lot of fiber laid for the Olympics, and so we have good images. And one of the most popular pages, the birthday page. So I will walk past people in the hallway, and I'm like, oh, happy birthday today. And they'll look at me kind of like, where'd that come from? How do you know? And it's just the buzz. Okay, so we see it. We got our database of birthdays. BBC Technology News. So we pull a bunch of RSS feeds, and we do various things. So technology news, science and nature news comes up. But we're expanding. So we've got a Slashdot page that's very popular. Just kind of mine it and pull off of it. What are the latest movies out on DVD? This is the stuff. I don't have time to look at all this, but every now and then I see one, and kind of interesting things come up. Popular one, webcams. Okay, just many of our people don't have a window in their office. What's going on in the world? So just showing different webcams. Times Square, Waikiki. There's a night one, various things. Blogs, starting to get at different things, boing, boing. iTunes top downloads, what's going on. Now the real popular page, San Francisco newspaper has wonderful day in pictures, and this one comes up.
When you say popular, is there a way for people to provide feedback on what they're seeing as they're walking down the hall? Or?
Not particularly, but I'll say in a second where we're going with this. PhD comic, which has actually become a very popular one. Turns out it's a Georgia Tech grad student. I did not know who creates this. James Egan, one of my PhD students, the buzz is his thesis work. And the focus of his work is getting at personalization. What we found in deploying the buzz is people they like a lot of things, but they're like, I'm not interested in this, but I want to see more. Or the webcams. I want to see the Lancaster cow cam, or I want to see, Swiss skiing or whatever. Or the weather page. I want to see the weather where my parents live in Pennsylvania or things like that. So what James is doing in his thesis work is looking at how can we personalize this and allow people to create collages that are more relevant to them, and in particular almost studying a kind of end-user programming level. So it may be when you get the buzz, the lowest level is you take the default system and you run it. Maybe one step up is think of it like cable TV channels, and you just subscribe or you don't subscribe. Maybe then another step up is some kind of property sheet dialogue to where you fill out what you want and you customize. Going up higher, you start programming. You're literally writing little modules of go off and pull this and look at that and how to get at it. But give it much more personalization and customization. Per the question, the new version actually, it's pure at screensaver though. So if it's running on your machine, you go to look at it, you bump it, it's gone. But we have an application version where you can drill down, get more info. We don't have a kind of feedback loop built into it. But when he deploys his personalized thesis system, we will have a lot of logging built in so we can get at what kinds of things people focus on and customize. And we want to study that. So the final thing I want to show you is, okay, the buzz is there. Can we get even more subtle? Can we have kind of ambient tools that blend into the environment? And well, ambient displays have been known for quite a while. Hiroshi Ishii's group really did a lot of the pioneering work here. And it resonates with Mark Weiser's vision of this calm technology, these things that are out in your environment and really have a strong focus on aesthetics. And many have been built, some of local interest right here, in fact. Lots and lots of systems. And in fact, the paper I have at AVI this year does a kind of taxonomy and characterization of ambient displays and some of the design dimensions and design archetypes within this area. But there's lots of different systems been built. So we built a system called the InfoCanvas. And information art, that's the idea, all right there. The idea is it's an LCD display that you would hang on your wall or on a shelf like a picture. And it's just some pictures. It's a representation. But the objects in the scene map to data that you care about, and they change very subtly to give you feedback about it. Okay? We want end users to be able to design the representation and as well as the mapping. What do these things correspond to? So this is my office, and I've got an InfoCanvas running. I got a little Mac Mini just sitting on my stereo, kind of driving it. And it's, I've actually got a picture coming up. Took a 15-inch LCD, ripped the bezel off, bought a $9 picture frame, and kind of engineered it together, and it works pretty well. And so this is one example. This might be an InfoCanvas scene. And we call them themes, so they're different. This is the beach theme. And there are different visual elements in it. And those elements can change. We found 6 basic kinds of changes. Sliders, so objects move position along a line, and their position encodes a value. Image swapper, simply it changes, like a color change, or what the little icon of what the object is, things like that. Appearance, so an object can appear when a state is true or disappear. Objects can change size. Population, I can get more of it to represent data. Or projectors are, we can take either images or text from web pages and put them onto your InfoCanvas, but we do it contextually. So if you have an image, you don't just put it, but you put it on a billboard or on a TV or somewhere where there would be a picture. So for instance, sliders, the plane. if the Dow is up 100 points that day, it's at the top of the scene, and if it's at the horizon, the Dow's down 100. Or airfares, you're monitoring a certain airfare, and whatever the current best price is where the crab is along the beach, left to right. Okay? Swappers, so a very literal one. Whatever tomorrow's forecast is what you'll see in the sky. Maybe the colors on an umbrella or the stock. I use this one. The traffic heading home is the woman's bathing suit color, red, green, yellow. On I-75 into Marietta that I go, whatever color is the current state. When the towel appears on the chair, I have email from my wife, perhaps. A beach ball that gets bigger or smaller with a bank account balance. Every 20 unread emails, I get another drink on the beach, and you can do that metaphor. And then projectors, the lead image from CNN.com, we simply put on this little sign on the beach. And we've developed a number of different themes. You saw the beach one there. We have kind of 3D photorealistic, where we took images and we did a little Photoshop magic and kind of pulled out objects. I had a wonderful undergraduate. She did kind of a Japanese pencil sketch kind of view under change. This is actually my favorite, the one that I run in my office. Some other ones. This one, I hung a student off the front of our building, and we took a digital image of the street in front of us. So the tech trolley there moves up and down the street, and more people can appear, and the trees get leaves or less leaves, and the bicyclist moves, and the lights change color, and things like that. So we can modify all these kinds of objects. Hey, here's my personal one that I have running, and it has a number of things. So that tells me where my parents live in Pennsylvania. It's snowing, and it's in the 20s because there's 2 apples there. And the Dow is up pretty good that day because there's 4 watermelons. There's 1 to 5, and it's just 3 is flat. The NASDAQ's up too because this coat's green. Traffic's moving very well because there's no stripes on the barber pole. So the more stripes it gets, the worse the traffic is that I head home. This and this are individual stocks that I monitor, and the fruit or the flowers change, green, yellow, orange, red, kind of how they perform. And the semi-transparency here is an indicator. It actually means the data is dubious. So the website may be down, or it has trouble connecting, and that's what we do. We do a kind of semi-transparent view to indicate this is questionable. The dog is the time of day, and it's just like from 8 a.m. to 6 p.m. He just moves slowly across the scene. This sailboat's an airfare monitor from like whatever price here to the end of the water. And I'm a golfer, so that's golfdigest.com lead image, whatever's on there. And from 12 to 1, the sign goes out to lunch instead of open. So just a little view that I have. The InfoCanvas is a big Java system. You have a question? Okay. It's a big Java system. We have back-end data harvesters to go out to the web. We're primarily doing web page scraping, do a little bit of RSS, not all that smart. But there's an XML mapping that at startup, essentially there are objects that have data and representations. And data is of different, weather, stocks, et cetera, things. And representations, there's the 6 basic types. And then just the mappings you'd expect. Where to move, what are the values to represent. We did a few studies of the system. In one, we looked at the InfoCanvas in comparison to a web portal style display compared to a pure text display that we designed. We encoded 10 pieces of information. You can kind of see them on these 2 here. Our participants came in the study, and the basic idea was this. They would sit down in front of a monitor, and for 8 seconds, we would put up one of these displays, and we would take it away. And then we had 10 questions. How was the stock market doing that day? How many unread emails did you have, et cetera? And we counted how many they got right. They had to learn the InfoCanvas mapping. They had never seen it before, so they had to understand what did the color here mean and what did the beach balls mean and so on. These they could understand pretty easily. But we did kind of study, ran through, and we found that people remembered significantly more information with the InfoCanvas than with the other 2. And it actually went InfoCanvas, portal, text, as you'd kind of expect. As text, you have to do much more sequential processing. You have to read over it. But what was encouraging to us, it was the result we expected, but what was good to us is our training for them to understand the InfoCanvas was about 3.5 minutes. Okay, and they basically got it. So they had to get the mappings, remember the mappings, and then see them in kind of 8 seconds and do it. But they remembered significantly more information with the canvas.
Roughly what percentage of additional information did they remember relative to the other two media?
It was roughly out of the 10 questions, it almost went, they remembered 6, 5, 4 items, very roughly. But there were relatively strong individual differences, but the ordering effect was consistent and significant across there. In a second study we did with the InfoCanvas, we actually built it and gave it to people to run. So we built 8 of them, and the building next to ours is a technology incubator. And we primarily use people there, but we built these and we gave it to them for a month to run. We started off with an initial interview where we went in, I literally, for the themes, we printed them out, and for all the objects, we printed them and cut them. And so they did their design on paper. And they lay it out, and we talked to them about the kind of information they would personally want to monitor. And so they did a design. I went away and hacked the XML code for like overnight. And we came in and deployed it. At 2 weeks, we came back in and interviewed them about how it was going, and they could make changes if they wanted. And then at the end, at 4 weeks, we went in and did a much kind of wrap-up interview. I'll show the 8 different deployments are here in offices. So it's kind of put on shelves on the wall. This particular one, the person worked in kind of a cubicle shared inner office, so many people could look at that. That became kind of a group display. Someone with 2 big Mac monitors, and they just put it up above, and some other ones kind of sitting on desks and shelves and so on. So these are the 8 people. They chose 6 different themes out of the 15 we had available. There was a low of 6 data items or visual elements to a high of 17 for actually the person who had the most. The mappings were no problem. Literally, the second day, they were, oh yeah, I knew what everything was, and that's not a...
So for non-tech people like grandma, who doesn't really know RSS web,
Yeah.
What kind of interface they need to do in order to connect that info?
Not good. So that has never been the focus. We got to a certain point, we had a kind of a beta of an interactive GUI tool where you would literally do your painting, draw it, and there'd be a little pop-up dot, do you want this to be weather or stocks, that would be much, maybe not for grandma and grandpa, but would be certainly an easier design rather than going in and writing the XML. But that project never came far enough along, but clearly that would be a logical next step. Of the transformations, the swapper slider and image display were the things that got used most. There were more direct mappings, like the weather and the sky, but there were a lot of abstract mappings. In an earlier study, my favorite one was we had an aquarium scene, and a woman who had a stingray appear on the base of her aquarium whenever the word evolution appeared on the New York Times science page. That's kind of what she's a biologist and researcher at the CDC in Atlanta, and she was stung by a stingray when she was little, and she cares about evolution and things like that, and she wanted to see that, and so that's the mapping she came up with, and it was meaningful to her, and something that worked.
Do you want to, for the previous result that you just said, do you want to guess as to why people were able to remember more through this kind of picture encoding than the other 2 representations?
Sure. I mean, we speculated a bit, and there's some interesting prior research about visual encodings and mappings. But I'd be curious to hear other ideas, or...
Yeah, we're hardwired. I mean, if this isn't offensive to anyone, I mean, I believe we evolved in an environment pre-text, right? We evolved in an environment of things, of physical things, and so that's just how we evolved to assimilate information. Text is something we kind of had to learn, so we have to kind of route it through that more innate mapping that's built into our brains.
It would be interesting to contrast that against a visual iconic thing that someone could. I'm pretty sure that what you had is something that you can't read in 8 seconds. And therefore, it doesn't matter how good people's recall in the text is, they don't have enough time to get it. So it'd be very interesting to do, stock market ticker, up, weather, rainy, very direct mappings next to each other.
In our web portal, we actually had about half of, so some literal mappings. Turns out there's a speed thing here where it was a kind of a mixture of visual iconic representations as well as text. So, the use of color and the down arrows and so on. But clearly it was, we really, in this particular display, were kind of targeting a kind of ecological validity with web portals. We wanted to come up with something that was fairly representative. But clearly we could do a purely visual, iconic, much more direct representational, and it would be an interesting comparison as well. Right.
See, I also wonder if it has to do with the variety of mappings you chose. So if, for example, your mapping was one thing is tied to the number of beach balls, and the next thing is tied to the number of crabs, and the next thing is tied to the number of drinks, right? So there's not much variety in the mapping there. They'd probably do more poorly than yours, which does a great job of spreading it out across a bunch of different.
Yeah, we pulled out each of the individual mappings in the InfoCanvas and looked at that too and wanted to see. And certain ones were better than others, but it wasn't a consistent, like all the ones that were the position sliders did best. That wasn't the case, okay? There were clearly ones that helped and added better, but there seemed to be no kind of actual consistent reasoning for that we could identify. So in our deployment, some of the comments in our end interview we got on running the InfoCanvas, things like, I could just glance over and check out something without searching for it, like going to Yahoo Weather. It saved time. It was quick. It was easy to learn for me what things meant, kind of quick. I like the fact I can look at it in one quick glance and get it okay and return to what I'm doing. With a website, I can take a half hour there. One of the big comments we got that people liked was the consolidation. How we had all these different pieces of data in on this one representation, and just, on the way in or out of their office, they could glance at it and take this in. This bottom one I really liked a lot. It's useful without being irritating. It doesn't feel heavy. Now, of course, one of the reasons it doesn't feel heavy is because it's sort of out of my normal line of sight. It's sort of a natural place when I lean back and I'm staring off, I can kind of get it. So my eyes kind of drift there through the natural course of things when I'm not particularly concentrating or something else. So it's been positive. It's been useful without being terribly distracting. Distracting was one of the things we asked a lot about, and people didn't really feel. At first there was the new technology of it, but the fact that it was there a month, they kind of grew accustomed to it. And in particular, a few people, it was a kind of, the person who I think enjoyed it the most was the head of kind of public relations for this technology incubator. So he had a lot of visitors. And he said a very common thing, they'd come in and they'd sit and they'd chat a little and it might be quiet. And the people would glance up, see it, and they'd be, oh, what's that? And let me tell you about the InfoCanvas. And so it was kind of an icebreaker, a little A lot of them thought it was one of his kids' drawings or something, and they actually thought they got digitized. But he really enjoyed using the tool. Some of the lessons we learned, question?
So one of the things that we concentrated on in Sideshow was being able to go from that little thumbnail of data to deeper and deeper representations of it. Did you have anything like that?
We did not in here. I think that was an early design decision we made to really keep it very ambient. So in an initial study we did with it, we simply had it be a second monitor on people's desks. And we got a lot of that, I want to click on it and drill down. And in fact, we have that capability. You can't drill down, but when you mouse over an item, the details of the data come out. So the average traffic speed or how the stocks are doing. In the latter study I showed, when we deployed it and put it on walls and things, it totally changed. The fact that it was this picture frame kind of thing, people thought of it like, oh, I get a little drizzle of information, and we got in our both midway and ending interviews very little of I wanted more details, or they said that was fine. I saw it, and I brought up my web browser, and I looked at,
Right.
Mm-hmm.
Yeah, I don't think making it an interactive service is the thing you want to do, but being able to get to deeper data on your computer that is keyed by this stuff and relates to it is the point, I think.
Yeah. Some of the other ideas, the consolidation I mentioned already. And abstractness and symbolism can be beneficial. People, why would you want to show, airfare as a crap? Well, it works. There were cases where you might want to hide something, a bank account balance or whatever. We didn't have much of that kind of data in our study, so that didn't really pop up, but that could potentially be important. I think it's a push tool, and I think, there's point cast, tickers, and push was hot and push died. And I actually think push should be revisited. I mean, the buzz in a way, and this. I think if it's done quieter, let me use that term. Push has potential. Personalization is clearly very important. That kind of one-size-fits-all on these tools just doesn't work. People want their own stuff in it. That's really, really important. And then the question earlier, we need better customization tools to get at that.
In your study, you did not let them customize, right? Would you anticipate that the scores would go up then if they could personalize it more, so that it was more meaningful?
Yeah, I would hope so. I don't know if that's a fair speculation, but I think if it is more personally meaningful, I'd be easier to digest, and both along the lines of information conveyance as well as just do you like it? Do you live with it?
Taking the eight test subjects, right, and then giving them the same thing, after having done it for a month, in the eight seconds, would have gotten 10 or whatever.
So again, in future work in this area, I think getting at more personalization, more customization for end users in these kind of ambient tools and displays that are around is one of the growth areas. So to wrap up, interactions where it's all about, in visualization, your end users' tasks are absolutely crucial. And then consider these kind of peripheral channels, these background notions for communicating information. My group's website has more information on all these different projects, and thanks for your attention today.
If you could go back the screen to the website, that'd be great. Thanks.
Okay. The Buzz, the screensaver, you can actually download that, and it's a very small. The client is just a Windows screensaver, and it does nothing on your machine. It's a very simple client that goes out, and the Buzz collage is a JPEG that's put on one of our servers, and it simply goes and gets it and puts it up as your. So you're going to get Atlanta and College of Computing information, unfortunately, but it's something you can run. It's very simple and small. We hope to have this new personalizable version of it ready within the next year sometime. We'll see.
So when you were talking about Buzz personalization, you told us a bunch about like skill personalization that seemed to me mostly to be you stop the Buzz screensaver, you go in, you interact with a bunch of settings and preferences, and then you go back. I'm curious whether you've given any thought to things like the more gentle recommendations as the movie to see. I'm thinking about like Pandora.com, where you bump it up. Yeah, I kind of like that image. No, not that one so much.
We've kicked around that idea a bit, and so my student is working on the design of the customization, and I think that's one of the things that's on his plate, but he has not been focusing on that kind of activity, and I'll push him a little harder on that to maybe think about it further. We have been thinking about it very much as you get it, you configure, deploy, and every now and then you step back and tweak it a little bit. That's the way we've been thinking about it.
Yeah, I think the TiVo model, although I have no TiVo, but seemed like the right thing. Like, oh, I clicked on that. I kind of like weather images. Oh, I get more weather. Or I clicked on, small children. Oh, more small children.
Yeah. I think that's a very good model. We've talked a lot about TiVo already, and cable TV channel packages, and you get to deploy this. And what's interesting in a way is he really wants to study end user customization and personalization, where this kind of peripheral awareness is simply the medium, the domain that we're looking at, It's going to be one of his big challenges is going to be, once he deploys, studying people in the community and how, why did you choose not to drill down farther and add extra webcams or something like that. And we're working right now on both low-level system logging kind of mechanisms to get at that, and clearly he's going to have to do a lot of interviewing and interaction with our end user base.
Well, I mean, I think evaluation of these systems is incredibly challenging. I started down the road with a stoplight that was attached to a build system, and it was just like, oh, I don't know,
Mm-hmm.
So by having the TiVo or the small nudgy thing like Danielle's saying, I mean, that's great data. Like, they were seeing it. Yeah. They cared enough to nudge it, and that can say a lot about usage, where otherwise it's peripheral. So yeah, maybe I looked at it, maybe I didn't. I don't think you're all, you don't want them wearing head trackers or something.
Mm-hmm. Yeah, absolutely.
Anyway, you can build a design.
Yeah, and I think that kind of thing can work really work well in the personal deployments in offices and things. We have a number of kind of public, big, and I'm a little worried. Yeah, well, I'm a little worried at issues of drawing attention to clicking on this and doing it, and that somehow we're kind of messing with the.
You stick two buttons next to it. Vote for this, vote against it. And the system gradually takes those into account, and stuff that keeps getting voted against stops showing.
TiVo again? We're right. That's the TiVo model too.
So the collage idea is really interesting. Would it be fair to say that it's, in a way, it's kind of like flattening a lot of information and then just sort of randomly accessing that flat information? So in your case, it seemed like there was sort of one access to setting it all up and determining what that information
repository or database to draw from.
Exactly. Now, so what if it all of a sudden became collaborative? You were talking about the community aspect of it. So we have various ways of, or we're starting to get various ways of collaborating to get information up on a website. But what's intriguing about this is the fact that it's, like you say, it's sort of ambient. It's not in your face. You don't have to create a hierarchy, or you don't have to worry about how you access the information because you're accessing it randomly. And what if it was a family, or like a family website that you could go to where it would just randomly show you what various, church community or
That's one thought we've had, that a clear thing is a number of the people at Tech have personal picture collections that they have chosen not to make publicly accessible on the web. But they could very much, here's my directory of images for grandma and grandpa to get collages at home on their images from. You could think about going in a little bit different direction, different kinds of data. So you're on collaborative, software development teams at multiple places around the world, and you have various metrics or statistics or data about what you're developing, and think about just having, big plasmas in the hallways so that you, glance past them. Oh, group XYZ, I see they just finished so-and-so, and they're having a meeting today on just this kind of peripheral awareness of those activities.
Can you define ambient and peripheral?
Okay. So read our AVI paper. I think of peripheral as the broader term, simply kind of being in your periphery in one way or another. So by that, I would think of a typical ambient display, so the dangling string at Xerox PARC that, network traffic, it moved, or, something on your wall, very physical, as well as on your main computer monitor in the corner, you have a little ticker. That's a peripheral display to me. I think of ambient displays as as being peripheral, but having a much stronger focus on physical artifacts, tangible displays, as well as aesthetics. Okay, they have a strong sense. I would argue many tickers have no sense of aesthetic. But ambient displays often have this kind of, we took electronic flowers and they bloom when the stock market's up or something like that. They really aren't precise terms. In our paper, we talk about some design dimensions of those kind of systems and thinking about, there seem to be a few kind of common classes of systems in this space that have been developed. If you send me an email, I'll be glad to forward that along. Okay.
I was just going to ask, when you have a public system like the Buzz, people talk about how do I get more information from the thing that I saw. But if it's, I walk down the hallway and I see something on the wall that was interesting, and when I get back to my office, how do I still remember?
Yeah, that's
imagine show me what was on the hallway 5 minutes ago kind of thing.
So it turns out we have on the Buzz website, there's a recent.html that has the last 10 collages up. And that's very good for me to create talks like this, to go get some of the collages and pull from it. But you could think of some kind of, I have my PDA and I capture somehow and work from there. But that, I've seen a couple of people that wandered by and have been, jotting a note for a URL or something like that.
All right, well, let's thank John again.